All right, now I'm going to show you how you can kind of approach writing some nested loops, and we're going to focus specifically on writing nested for loops. So let's say I wanted to write nested for loops to produce the following pattern. Now, you should notice that here we essentially have rows and we have columns. And we have 4 rows and we have 6 columns. So 1, 2, 3, 4, and then my columns are 1, 2, 3, 4, 5, 6. I don't know what's going on with my pen. All right. All right. So let's think about this. So in row 1, we have 6 x's. In row 2, we're going to also have 6 x's. In row 3, we have 6 x's, and in row 4, we have 6 x's. So it looks like that the number of values in a column is going to be pretty consistent. And so let's think about how I can do a loop to make 6 x's, and that's going to be my columns. I'm going to have 6 columns. So for that, I can say for, and I'm going to use C for columns, I'm going to say for int c equals 0, c is less than 6, c plus plus. Now, you might say to yourself, well, why are you doing that when you can just do a print line and do x in it? And the answer is we want to be able to generalize this, and so we want to figure out how we can do that. All right, so I'm going to say int c equals 0, c is less than 6, c plus plus. And that's going to do 6 times. Could I start at 1 and go less than or equal to 6? Sure. All right. So what am I doing? I'm going to continuously, in a print statement, print an x. So this should give me something for basically 1 row, right? 6 times I'm going to print x. And then after I do that, I'm going to want to move on to a new line, right? So this should give me the 6 x's in a row, and then I move on to a new line. Now, how many times do I want to repeat it? Well, in this case, there's going to be 4 rows. And so I'm going to put this code inside an outer loop, where I'm going to say, I'm going to do it 4 times. I'm going to call that R to represent the rows. And I'm going to say R equals 0, R is less than 4. Now, could I say 1 less than or equal to 4? Sure. Basically, as long as this is going to repeat 4 times. And then I'm going to say R plus plus. Okay, so here, remember what's going to happen is we're going to pause and we're going to do this and then move on to a new line, and then we'll do R plus plus. So basically we pause at each row, we do all the x's we need, and then we move on to a new line. Let's see what that would look like for coding, right? So if I come to my JGrasp, we said that, let's just start with our first row, getting all that to work. I'm going to print an x. And then after that, I'm going to move on to a new line. All right, so just to show you that this will work for the first row, right, we have our 6 x's. And then we want to repeat this a total of 4 times. And so that's where we came in with R equals 0, R is less than 4, R plus plus. Because that's going to repeat that one line of code, or one line of x's, a total of 4 times. Now this is important, remember, because it means that we're moving on to a new line after we printed the 6 x's. So let's see how that works. All right, so you'll notice that here we had 4 rows of 6 x's. So 4 rows of 6 x's, 4 rows of 6, see? And that's kind of I like starting at 0 because it sets us up for success for one of our future units. It's just a preference at this point, but in reality, it is going to set up good habits for the future. All right, so I like to start at 0 and go less than to 4. All right, how can we generalize this for any number of rows and any number of columns? Well, let's think about this. This worked for 4 rows and 6 columns. What if I change this 4 and this 6 to represent parameter values, where I said this is less than rows and this is less than cols? That's just a very minor change, but here you're setting yourself up to generalize it, where it may not be 4 rows, it could be 1 row, it could be 20 rows. It may not be 5 columns, it could be 15 columns. All right, so that's why it's not so much important, I guess, when you know ahead of time that it's always going to be a fixed number, right? I could have just done a systonout.println with 6 X's inside my quotes. But now this setup allows me to generalize it for any number of rows and columns. So if I come back to here, and I want to generalize it, where it doesn't not just work for 4 rows and 6 columns, but if that was a generalization and it worked for however many rows were being passed and however many columns were being passed. So if I come up here, you'll notice, I'm going to comment this out, not uncomment that. Let's see how that works. Does it work exactly the same where I just generalized it? And the answer is yeah. And so now you might say, okay, well, Miss Gilroy, then why do we need this if it's still going to be 4 and 6? Well, my answer is it doesn't have to be 4 and 6. I could make this work for 5 and 2. You see, 5 rows, 2 columns. I can make it work for 10 and 10. So I have a 10 by 10 assortment. Except now you'll notice I didn't have to change anything in my loops. I just changed what was passed to those values. Okay. All right, let's do a more challenging one. What about if I wanted to produce this pattern? So what you'll notice is that we have rows with X's and O's. So let's think about this. I'm going to want to do a loop that prints my X's. I'm going to want a loop that prints my O's. So I'm going to call this row 1, let's say. What did we notice in row 1? In row 1, I have 1 X followed by 5 O's. One of these days it'll write. There we go. What about row 2? Well, in row 2, I have 2 X's and 4 O's. In row 3, I have 3 X's and 3 O's. In row 4, I have 4 X's and 2 O's. In row 5, I have 5 X's and 1 O. And in row 6, I have 6 X's and 0 O's. So let's try to do one thing at a time. All right, let's see if I can get my X's to print, and then we can worry about our O's. So I noticed that in row 1, I have 1 X. In row 2, I have 2 X's. In row 3, I have 3 X's. In row 4, I have 4 X's. In other words, however many rows there are, that's how many X's I want. So how would we write that in code? Well, let's go try it out. All right, so I said that I want the number of X's to match the number of row we are. So I'm going to start out in row equals 0, R is less than, in this case, 6, because we have 6 rows, R plus plus, and I want the number of X's in the columns to match the number of the row number. Now let's say I'm going to do this, and this is wrong, but we're going to see why it's wrong. So let's print an X, and then I'm going to do my print line so I can move on to a new line. All right, let's see why this is wrong. So let me comment out this and uncomment this. All right, so here, if I were to compile it and run it, you'll notice I have 6 rows, but instead of having a varying number of X's, I always have 6 X's. And the reason is you're always going from 0 up to 6. I don't want to always go from 0 up to 6. I always want to go from 0 up to however many rows there are. And so I don't want 6 to be my ending condition value. I want it to be dependent on how many rows I have. And so what if I change this to be R? Because remember, the first outer loop iteration, R is going to be 0 and then 1 and then 2. And then I might say to myself, oh, hold on, when C is 0 and R is 0, strictly less than is never going to run. Let me change this to less than or equal to. All right, let's see how that works. All right, okay, so now look, and here we have 1x, 2x's, 3x's, 4x's, 5x's, 6x's. So if you want to have a varying number of values in columns, you don't want this to be a hard number like 5, 3, 2. You want it to be dependent on, in this case, the number of rows there were. Okay, so we have our x's to work. Now what about our o's? You'll notice here we have 5, 4, 3, 2, 1, 0. So again, we don't want to have a constant amount of o's in our columns. We want it to vary. So we are going to have to figure out how does this relate to the row number. All right, well, let's think about this. And I started my rows at 0, so this is actually not super helpful right now. In row 0, 1, 2, 3, 4, 5. All right. I want 5. So in row 0, I want 5 O's. And that should be O's. I want 5. All right. So in row 0, I want 5. So let's just start this out. I'm going to do it incorrectly. Now I'm going to reuse C. And the reason why it's okay to reuse C is because here when it's declared inside a loop, it only lasts for the loop. All right. So I want to do 5. So let's just make it so that way it works for 5. So I'm going to say C equals 0, C is less than 5, C plus plus, and let's go ahead and print an O. All right, so this is wrong, but let's see what's going on so then we can make adjustments. All right, so you'll notice that my X's worked, but now I'm always getting 5 O's. Now, how do we make it so that way it's going to vary? Well, we're going to make this somehow vary with R, because R is changing. It's just after every row, it's going to change. So if I have, let's say, 5 in my first when R is 0, I want 4 in my next when R is 1. And then I want 3 when R is 2. And then I want 1 when R is 4. So you should notice that if I were to subtract by R, 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3. So this is going to vary depending on what row number I am on. And the most it'll be is 5, and then when I'm in row 5, 5 minus 5 is 0. So let's see how this works. All right, so it looks like the pattern. Is this tricky? Yes, these are more tricky problems than just straightforward ones where you have numbers or even when your variables are independent of each other. But when your number of columns depends on the number of rows, you're going to have to make sure that your inner loop condition shows how it relates to the outer loop variable. So in this case, this was strictly just comparing it to the rows, but here we had to do a little bit of calculations. You have to play around with it. You have to try it out. You have to test it until you get something that works.